In this video, we're going to take a look at the addition rule for probability. And so the first thing that we need to know about is a compound event. So a compound event is simply any event that combines two or more simple events. Remember, a simple event is an event that can't be broken down any further. And so with a compound event, usually we're thinking about things like the probability that this thing happens or this other thing happens. And when we use the word or, we tend to think of the addition rule. We might also see a compound event where we're talking about the probability that this thing happens and this other thing happens. And when we use the word and, we will tend to think of the multiplication rule. We'll talk about that in section 4.3, but for now we're going to look at the addition rule. We won't see the rule yet. We will develop the intuition for how do we find this or probability. And then later on we will look at how do we think about that and how can we write that in a more general fashion. Right, so let's look at an example. So here we have employees at a certain company are tested for drugs. The results of the test are shown below. A positive test indicates the drug was used, and a negative test indicates that a drug was not used. We want to find the probability that a randomly selected person either uses drugs or had a positive drug test. And so when I see that word or right there, that's going to lead me to think I'm probably going to be using the addition rule. We haven't talked about it yet. Let's think about the intuition of this. So we want to know what is the probability that a person, let's first think about probability a person uses drugs. So those that use drugs, they're given right here. If we add 41 and 9, we get a total of 50 people that use drugs in this particular company. We want those that use drugs or those that had a positive test. And so those that had a positive test, those are represented right there, the 41 and the 99. So if we add those two values together, we get 140. So we're going to take 50 plus the 140. However, you'll notice that 41 right there, we actually counted that number twice. We used that number as we were getting this value of 50. We also used that number as we got the value 140. So we don't want to double count anyone, so we subtract it out. So we take 50 plus 140 over the total number of people. So this is 860. 9 plus the 851 gives us 860. And 99 plus 851 gives us 950. Adding those, either the rows or the columns, gives us a total of 1,000 people. Right, so if you add all four of those numbers, you'll get 1,000 people. So when we add these things together, we get 151 over 1,000, or, let's see, 151, sorry, not 151, 149 over 1,000, which as a decimal, that would be 0.149, or as a percent, 14.9%. Right? So that would be the probability that a person either tested positive or they used drugs. So let's talk about what the addition rule does, how we do that in general. So in general, to find the probability of A or B, where A is some event and B is some event, we want to find the total number of ways that event A can occur, add to that, plus the number of ways that event B can occur, and then we want to subtract out, so minus the number of ways that both can occur. Right, so that's what we did up here. We took all of those where A can occur, plus all the ways B, so the number of users plus the number of positive, minus the number that were both users and positive, because we've double counted those. And so with the probabilities, we can do this and say it's the probability of A plus the probability of B minus the probability of A and B. Right. In this Venn diagram, if this is A and this stuff here is B, we're looking at the probability of A plus the probability of B and you'll notice that this stuff right here in the middle, that was double counted, so we end up subtracting it out once. So that's how we find probabilities using our addition rule. Two events A and B are said to be disjoint, or we might use the word mutually exclusive, if they cannot occur at the same time. So the probability of A and B is 0. Right? The probability that someone is a freshman and a sophomore, that is 0. You are either a freshman or you are a sophomore. You're not, well, I'm kind of a freshman sophomore. That class rank is built on the number of credit hours that you have passed. And so if you've hit a certain number, you're now classified as a sophomore. You can't be, you're not really both. All right, so let's revisit that previous example. Let's think about this example in the context of the addition rule. So we're again going to find the probability that a person uses drugs or had a positive drug test. So we had a total of 140 people there, and we had 50 people here. So the probability someone uses drugs is 50 out of 1,000. The probability that someone tested positive is 140 out of 1,000. And those that we double counted were those 41 out of 1,000. So we went through exactly the same process. We just thought about this is the probability of A, so probability they use. This is the probability they tested positive. This is the probability that a randomly selected person both tests positive and uses, because those 41 people, they were included as part of those 50. They were also included as part of the 140. We want to make sure that they are included. We just don't want to double count them. And so again, we end up with 149 out of 1,000. We have previously defined the complement of an event. Right? So the complement of an event, A, is the event in which A does not occur. And so we have some formulas associated with the complement rule. If I were to say something like, it will either rain tomorrow or it won't rain tomorrow, how confident can I be in that statement? Well, I can be absolutely confident in that statement. It is either going to rain or it is going to not rain. If it sort of rains, it rained. So the complement rule tells us that whenever we say, look at the probability of an event plus the probability of its complement, that should always add up to 1. We should always be certain of that. And we can modify this. We can subtract things. So if we subtract the probability of A complement from both sides, we could say the probability of A is 1 minus the probability of A complement. Or if we start with that first formula and subtract the probability of A from both sides, we can say the probability of A complement is 1 minus the probability of A. All right, so let's look at an example. A recent survey of 5,238 people found 3,111 found YOLO to be the most annoying phrase. Find the probability that a randomly selected person will not think that YOLO is the most annoying phrase. So the probability YOLO is most annoying. There were 3,114 out of the 5,238. And so the probability it is not the most annoying would be 1 minus that. 1 minus 3,114 out of 5,238. And if we go through and take the time to calculate that, 3,114 divided by 5,238. This value here is 0.5945. So 1 minus that value is 0.4055. So that is the probability that a randomly selected person will not think it's the most annoying phrase. In the next video, we're going to take a look at our multiplication rule. We will see you there.